So what we are doing with the universal laser system is that we are turning a commercial wearable polymer film into highly graphitized graphene structures.
We've got the ability to draw now graphene on plastic. Generally, graphene needs chemical vapor deposition, so it's a very high temperature, it's in an inert atmosphere, and you have to keep it away from air, moisture, everything. Now we just do this in air, writing it on commercial plastic films, and wherever the laser hits, you form graphene on the surface. Once you make these little arrays, then you just put a little overcoat and electrodes, and you get supercapacitors. Supercapacitors are like batteries, but they have much higher power than batteries. And so what we're doing is we're moving toward flexible electronics that will allow these to flex and be made in air. So what we do is we just take a commercial laser system like this universal laser system, and we use it to write patterns on this commercial plastic film, and then we just encapsulate it, and these are now energy storage systems that can store energy and give the energy back just like a battery would do, but with a much higher power, and that's what we're moving toward, and also toward flexible electronics where we can take these and have them flexing when we're moving. We can put them in shoes, we can put them in clothing, because they're entirely flexible. That's the idea, to be able to build structures very rapidly, roll to roll. So just as newspaper print goes from one roll to another and the ink is written on it, this is what we would do. We would have roll-to-roll plastic films going, and lasers would just print the patterns that would then be used in electronics. But it's not just directly in this way. We can take these, we can also electrochemically coat them and make pseudocapacitors, which have even much higher energy than this the supercapacitors would have. So we can move this into other domains. In other ways, what we can do is we can write patterns and then scrape off the graphene and use that graphene in other catalytic reactions. For example, we have shown that we can use it to split water. This is taking water, H2O, and converting it to H2 and oxygen. So it's splitting water, and then we can take that hydrogen, that H2, mix it with oxygen from the air, and use that in a fuel cell for these renewable energy packages. This is what we've been able to create here.